Hello everybody, this is our second in-class demo of the semester, and it's this ball and beam project. So the objective of this is there's a little motor shaft right here that we're trying to control. And the way we're trying to control it is so that this ball will roll on the beam and we can position the ball anywhere on the track that we want to, theoretically. If we can control the motor at just the right rate, then we can set a dial and control that thing. And so what I'm going to do is just turn the power onto this thing. And we have a digital multimeter here so that we can check out what's happening. I'm just going to take, it's got a built-in power supply here, so I'm going to plug into that, and I'm going to take the power supply over to this 1K rheostat so that I can vary, so it's not just 12 volts all the time. I'll be able to vary it. And then I'll take the output from that thing, and I'll read it in the DMM over here just to see what's going on. So I can take that, put it over here. Then I'll take a ground wire and hook it to the other end of the rheostat like that. Then this output I'm going to take and put up to the motor like that. Then I'll ground the other terminal of the motor. So this little symbol right here is the motor. So theoretically if I put positive voltage to that thing, it'll rotate in one direction or the other. So I'm going to go ahead and plug this thing into the ground, and you can see it just moved. Now I'm going to go to the other end with that rheostat, and now if I increase the voltage on that rheostat, you can see I've got, well, just a few millivolts on the DMM, but as I turn this knob, that increases the voltage. And now the motor, I'm putting constant voltage to the motor, and it's just sitting there rotating brainlessly. So what I want to do is put the right constant voltage to it so that it holds its position. And so what I need to do is, since I put a positive voltage to that thing, we can see that the direction of rotation of the motor is clockwise, correction, counterclockwise. You can see it rotating in a counterclockwise direction there. So I'm going to go and record that so I don't forget it over here on the board. I'm going to say motor positive voltage is going to make it go counterclockwise. Now I have a couple of other items on this demo device here. One that reads shaft angle. So that's like the angle of the shaft on this motor. So if I take that shaft angle, which is right here, and plug that into the DMM, and I'm going to need a ground wire for that. Okay, I'm reading about 1.5 volts on the DMM, with the shaft angle being obviously like in the downward direction with the ball on the right. So that shaft, when it's clockwise, is reading a positive voltage. Now it's up to 2.6 because I lowered it a little bit. Now if I take it back to about a level position, I'm getting pretty close to 0 volts. It's reading on the millivolt scale right now. And it just went negative. So if I keep rotating it in the counterclockwise direction, I'm getting negative voltage. Okay, so I'm going to say shaft angle. I'm going to say counterclockwise is negative. So I get a negative output from the shaft angle detector if I make the beam go in a counterclockwise direction. Now I'll hook this thing up to ball position, which is over here. And I can look at the DMM. Now the ball is all the way to the left. So I have a negative 3.5 volts with the ball all the way to the left. Let me roll it to the right. Now I'll take this thing. Okay, there goes the ball to the right. Now it's positive 4 volts. So I'm going to write up here on the board again, ball position. And that will be to the right is positive. Okay, so now if I go up here and refer to the homework problem, this thing shows 2 op amps in series, and they have capacitors and resistors in them. So I have this Vx here. That is the position of the ball. Now this V set point, that is like my input to this thing. So in other words, if the ball is at a positive position, in other words, if it's to the right, and I put in more voltage to it, it's going to make it go to the left, because it's going to reduce the voltage between these 2 terminals. So this thing says to hook up the set point, which is this thing right here. Hook it up to the input, to the positive leg of that first op amp, which is this guy right here. And that one doesn't reach, but I can use this. I'll put that right there. And this knob I'm going to use to vary that voltage. And so now I'm going to take the ball position indicator, which is this thing, and put that into the other leg. But I'm going to need a real long wire here. I don't know if we have any long enough for that. Well, I'll just put 2 of them together. That's going to go into this leg of that first op amp. So what I've done now is just what this drawing says to do. Put my voltage for the set point here, that's my input. I'm putting the voltage for the position of the ball there. And then I'm going to come out of that first op amp and go into another op amp. So let's do that. The other one that has capacitors is this one on the far right. So I'll take this from there and put it into the far right there. So I just made that connection right here. Now I'm going to take, it says take this V theta and put that from that's the voltage coming out of the shaft angle detector. I'm going to take that hook it up to the bottom of this other op amp. That's this leg right here. Then the output from that second op amp goes to the motor. Now I'm going to hook it up to the motor via this power amplifier. Because these op amps don't have quite enough horsepower on their own to drive that motor, so they gave us this power amplifier right here. And then just a short wire from the power amplifier to the ball. Okay, so now you can see that this thing, you can see it spazzes out a little bit. It quivers around and stuff. And that's some of those higher frequency oscillations that we get. So in other words, if we have like a whole, this is going to be a, I think we can see from the diagram up there, this thing's going to be a pretty high order system. And I'll put that on a separate PDF file for you. But if we have roots that are like up here and down there, then you get that quivering that we can see where that ball sits there and shivers. That's like real high frequency oscillation.